Hi everyone, thanks to be here for this talk about integration testing. Yeah, testing at the developers conference is not super popular. Some people are already leaving because they understood they are in the wrong room. I'm Nicolas Fränkel. I'm a developer. I'm working since like more than 15 years with Java, and recently I changed jobs. I'm a developer advocate, so I still try to code. And I'm working for a company called Exoscale. And Exoscale is a cloud company, but the big difference is we are located in Switzerland. So there is no Cloud Act, and your data is protected. Actually, it's also, it has also a very great support. So if you happen to want to host your data outside of the greedy ends of the American government, yeah, you can think about us. So what I will try to do in this talk, I will try to sum up what is in this book. This book is the best book ever because I wrote it. And it came from the conclusion that there are a lot of books about testing, but mainly unit testing. Everybody tells you how to unit test stuff. And in fact, I can understand why, because it's quite easy. The scope is super limited. There are not that many constraints. The rules are straightforward. You just follow them, and then you've got unit testing. Integration testing is another huge beast. So let's start. Testing. I mean, there are a lot of testing. You can also, like I mentioned, live unit testing, integration testing, performance testing. But in performance testing, you might have load testing, endurance testing. Then you've got mutation testing if you want to test your test. Then you've got penetration testing for security. You got at one point, I stumbled upon a page that listed 100 different kind of testing. In this talk, I will limit myself to integration testing and unit testing. And I will just try to define what is integration testing with my semantics so we can agree, and then we can go further. So unit testing, in every book you find it is unit testing is you test a unit in isolation. That's really the rule of unit testing. And in the Java world, the unit is generally the class. Sometimes the method, but generally it's the class. And I define integration testing by testing the collaboration of units together. Make sense? Great. I like to take the example of a prototype car. Prototype car, not a car, but just a prototype car. And in that case, I define unit testing as testing every nut and bolt that composes the car. Integration testing is just like you assemble the car and you go on a test drive. So far, so good. And for me, I have a lot of trouble with people opposing the two. You see some people saying, hey, you should only unit test because that's blah, blah, blah. Or, hey, you should only integration test because blah, blah, blah. And I think this is very, let's say, no. So this is recorded. This is not stupid. This is a lack of awareness. Because you actually need the two. Who here, as a project manager, would just take the prototype and test it in real condition without having tested the pieces? It's a huge risk. It takes you a lot of money, of effort to assemble the car. And if something goes wrong, that could have been prevented because there was some faulty nut or bolt. On the other side, I mean, you cannot just test the pieces together and make sure that the prototype cars actually can drive. It's not possible. So the first rule, if you should remember something out of this talk, is don't oppose them, just use both. Now when we start talking about integration testing, as I defined it, you need to assemble pieces together and you need to test the collaboration. So that the first stuff that is different, that is new, when you compare it with unit testing, is that you need to define what you want to test. It's not only the unit, it's not only the class, it's the system under test. And the system under test can be as small as two classes together. I mean, two classes that need to collaborate, or it can be as huge as the whole application. First thing to define. And in that case, if you want to define a small system like two classes, those two classes, they will get input from somewhere when it's assembled into the huge system, and they will produce something. And it's exactly the same when you do unit testing with a class. You need to test the class in isolation. Now you test the system that you defined in isolation. So just reuse the same lesson. Use dependency injection and test doubles. Dummy, mock, stubs, spies, fakes. Everybody is familiar with those notions? Great. Also, something that gets me, like, I wouldn't say angry, but sometimes a bit stressed is, hey, let's test everything. 10 years ago, I had to fight for people to, like, write unit test, automated unit test. Nobody wanted to write test. I mean, test was just like a sheet of paper. You had to say, yeah, I tested it. But, you remember that time? No? Nobody remembers? I'm too old for that? Yeah. My life was not that funny at the time. And now I have to tell people, hey guys, 100% code coverage, stop it. It's no use, you know, that's over quality. So testing is about return over investment. And the problem with integration testing is, yeah, you want to make sure everything works, and that's fine. So you want your system under test to be the whole application, that's fine too. But the problem is that the bigger the system under test, the more fragile it is, the less maintainable it is. And then the less the return over investment is. So another rule is, you probably are familiar with the testing pyramid. Yeah, I didn't invent it. So the bigger the system under test, the less number of tests you have. So at the bottom of the hierarchy, you tested everything nicely, every nook and cranny, every corner case. And as soon as you start having bigger system under test, well, you don't need to test everything. In the end, if you have a big application, a big test that tests the application, then you just test the normal path. I usually take the example of an e-commerce application. I worked in e-commerce for a long time. Okay, you just test the checkout. Perhaps if you have a very big site, you test anonymous checkout and like authentified checkout. It's enough. Put stuff in the basket, order, pay, fine. No more. Otherwise, you run the risk of having to pay the debt of maintaining your tests. And they are very huge costs. So challenges of integration testing. In general, integration testing is frowned upon because the tests are slow. With unit testing, you expect your test to run under, like, how much? 10 seconds? 1 minute? Let's say very fast. Second problem, they are fragile. How many times does it happen that one test is green, day 1, red, day 2, then green again? Not funny. And when something happens, and it happens, they are super hard to diagnose. So how do we cope with that? Tests in general are slow, not because of the code, but because they depend on infrastructure resources. They need to talk, I don't know, to a database. They need to talk to a file system, or worse, a web service. Or you run your stuff in a container. You run your stuff on Java EE. Or Spring, a bit better. So that's number one issue. So how do you cope with that? Well, you cannot make your tests run faster in that case, but what you can do is you can separate your unit tests from your integration tests so that at least your unit tests are executed first. So if they fail fast. How do you separate them? It depends on the build tool. So who is using Ant? A couple of ants. Sorry for you guys. Who is using MAVEN? Yeah. Who is using Gradle? I hate Gradle. Sorry. It's recorded, I cannot say stuff. So I will talk about Maven because it's established, and I think that if you are using the other build tool, then you can apply the same lessons, or try to, because you will need to code it. So this is a Maven lifecycle. The Maven lifecycle is, you've got like phases that are stable. You cannot add them. No, you cannot add some of them. You just have them. You cannot do anything. It's like stable. And then there are like plugins that are tied to a phase. So when you Maven test, you like execute every phase that comes before tests, including compile, and you execute the goal test of the Surefire Maven plugin. The Maven Surefire plugin is bound implicitly by default to the test phase. And what runs by default is every test that ends with test, that starts with test, or that ends with test case will be run, whether JUnit or TESTNG. That's the default one. That's why it's very easy. You start with Maven, you write a test, it gets executed, that's fun. Now for integration tests, what the people do, they newly copied the Maven Surefire plugin. They called it the FAILSAFE plugin, and it has different default. It's considered, it will be run with the Maven's FAILSAFE plugin if it ends with IT, starts with IT, or ends with IT case. I mean, that's not rocket science, right? Now, there is an issue with like integration testing in Maven that there is no a single phase, but there are 4 phases. There will be like a setup phase, there will be the testing phase proper, there will be a teardown phase, and then there will be a phase that will check your tests will be executed correctly or not. So that means that all your tests will run, and only at the end will you, in the end, check that it's failure or a success. Other fun stuff, it must be bound explicitly in your POM. So if you write an IT class in the SSC main tests and you configure nicely the Maven FAILSAFE plugin, it won't run. You need to bind it explicitly. And again, that is not rocket science. You just say, oh, okay, I have executed the integration test goal of the Maven FAILSAFE plugin in the integration test phase and verify as well. You can also do it in a parent POM, so you are not bothered anymore. If you need pre-integration test because I don't know, you want to set Tomcat up and like post to stop Tomcat, you can do it as well. About continuous integration, a unit test are supposed to run at each commit. I hope everybody does it. Who runs a unit test at each commit? And the other are sleeping, I hope. The problem with integration tests, since they are not that fast, if you do the same, if you commit very frequently because you have a very huge software factory of like, I don't know, 100 of people, and you commit, I don't know, every like half an hour, if your integration tests, they run for 1 hour, doesn't work. So you have to like, again, that's what I told you, integration testing is much more complex than unit testing because you need to ask yourself questions because they are not like ready out of the box answer. You need to think about it. What is the good frequency in my context? And that only you can answer. You can run them daily, hourly. It depends. So you need to check like how often you commit on average, how long it takes to run your integration test, and then decide what to do. Other problem of integration tests, they are fragile. And the problem, again, most of the time, it's because you are using external resources that are not under your control and multiple ones. Basic stuff, web services. I'm dependent on a web service. I want to check that it runs correctly with the web service. What happens? Sometimes the web service is down. Whether the fact that the web service is hosted by you or a third-party provider is relevant. Sometimes it will be down anyway. So there are a lot of infrastructure resource, actually. I mean, the file system is an infrastructure resource. Time is an infrastructure resource. I have a nice, well, I will tell you afterwards. Database, web services, mail server, FTP server. Your application is not only code. Every time you need a dependency, then probably it's an infrastructure resource, and that creates problem because it's not up all the time. So if you are using time, and now I can tell you my story, is that at some point I designed myself, it was a long time ago, yeah, now I've learned from it, don't worry. I designed something that needed to activate on every Monday, I don't remember the time. And then I wanted to test it. So if you design your system incorrectly, you need, for your test, to change the system clock. No, don't do it. No, it's better. You know how to use dependency injection. Okay, it's the same way here. You design your class to accept a time, whatever it is, and then to run depending on that time. Not directly get the time, but let your class be injected with the time. Also, in the Java 7, Java 8, I don't even remember, there is this new abstraction called file path instead of file. Yeah, use it instead of file, if you can. I mean, some APIs still use file. I'm sorry for that. But if you can use the path, it's really like an interface. You can do whatever you want with it. Whereas the file, it's bound to the file system. Databases. I mean, who is not using a database? Everybody uses database. You want to persist your state most of the time. So if you want to test the service layer, it's easy because you learn to mock the repository. But if you want to test the repository layer, how do you make sure that your SQL statements are running correctly? You cannot mock the database. You cannot expect something that you will expect anyway. So it doesn't work like that. In that case, well, you use the same stuff as for unit testing. You use fakes. And probably you know about Oracle database, which is the database I've used nearly forever. So what you can do, if you are using an Oracle database, you can use the same database as in production, but one schema per developer. If you have 20, 30, 40 developers, your DBA will probably not like you very much. What you can do otherwise is you have to install Oracle Express on every developer's machine. Then your developer won't like you very much. Or you can use H2, which is not Oracle database, but it has compatible modes. And the problem is that, again, it's a trade-off. You have to think, what's the risk? What is better? Either you are standing very close to real stuff, everybody has an Oracle schema, and it's expensive to set up. I hope not that much now, but it's expensive because it costs space, money, whatever. Or you are using something very fast, but then you are not sure it will really run on the production infrastructure. It's up to you. H2 has an compatibility mode with Oracle. It's up to you to assess the risk, whether that is good enough. I guess that if you are doing Candy Crush-like stuff, it's completely acceptable. If you are doing surgery software or flight-related software for planes, perhaps not that much, because the risk is huge. So again, it's context dependent. There is no easy answer. That's up to you to think about that. Web services. Who doesn't use web services as a dependency? Yeah, no, you are scratching your... No, you are not scratching your head. You are really... I love your life. For all the other poor souls who are dependent on web services, it's really bad to have them during integration tests because, yeah, they are slow, they are fragile, something will happen badly. So you can think about it saying, okay, whether they are hosted, it's better. If they are hosted, that's worse. But if they are inside, we are developing them, it's more reliable. No, that's not true. They are not more reliable because they are inside. The other way to look at it is, okay, are they traditionally SOAP stuff or modern like REST stuff. And there is an answer how you can cope with that for every architecture. Use fakes. So I don't know if you know this little micro framework called Spark, which lets you, like, in a few lines of Java, or even now there is a Kotlin version, like create a web server which can, like, interact. It's very easy. And this is an example, and I think that even if you don't know Java, you set the port, and it tells you, hey, if I'm called with the hello stuff, then I will return the hello world stuff. If I'm called with user / something, there is a binding, I can, like, return it. If something like that happens, I'm called from private, then I can say, oh, 401. I mean, in a few lines of code, you can set up your fake server. I mean, I don't know if people are using it for something else than tests, probably, but for tests, it's really great. Really, really great. In a few lines of code, you've got your server, it's done. And then you cut the dependency with the flaky web service. How can you do that with SOAP? Well, it's possible to do the same with SOAP, right? But, I mean, it will be very hard to craft the response. It will be a lot of, like, boilerplate code. Who uses SOAP web services right now? Yeah. That's what I was afraid of. Yeah, I'm sorry for you guys. And the worry won't be terrible because, yeah. So who knows about SmartBEAR, SOAPUI? Yeah, everybody does. It's fun. You just click around and magically you have a guy, you have a good documentation, it understands everything SOAP needs, and you can set up your stuff very easily. So the process is you need to get WSDL, the whistle, you create the mock service, and then you run the service, and then you say, I want to use that web service. Yeah, the only thing is that first, crafting the adequate response is not that fun, because yeah, you might have like a big payload of XML, that's SOAP for you. And the problem is that what I described just before, you need to run it in an automated way. So there is no guy possible. Hey, it's fun. You can do it with code. Yes, there is an API for SOAPUI. Unfortunately here, you need the WSDL anyway, and you have to craft the response anyway. But at least you can run it in an automated way. Yeah. Didn't find any better, sorry. I have a couple of like tips. I would say when you want to fake those web servers, please try to keep the validation super, super simple. Don't try to be smart saying, hey, I will like factor that because it's don't repeat yourself in my test. So, hey, it's written here, it's written there. So let's create another stuff. And then your tests need to be tested again. Doesn't work like that. If possible, always try to write your tests so that they are like single page read. You can understand the test without like switching to another file. It's not always easy. Real engineers don't like it. They, oh yeah, let's optimize. But in that case, it's better. Be a little verbose. It's nothing mind-blowing. In container testing, so far we know how to test collaboration between classes, and we were able to set the boundaries with external dependency and then mark, fake them, whatever, depending on the type. But we forget about the most important dependency, which is the container itself. Hey, everything works in Spring, and when I deploy it, poof, it doesn't. Hey, everything works in my test, and then I deploy it to my Java EE server, it doesn't work anymore. Who here is a Spring user? Who here is a Java EE user? A few hands, it's good. Okay, if I don't have enough time, I will skip the Java EE part, but it will be in the slides, so you can check it anyway. I will start with Spring. So the problem with Spring is how we test that the configuration works. And that's an issue. That means that first you need to design your configuration so that your configuration must be tested. That means that there is no self-annotated classes. I insist. I hate self-annotated classes. And there is one reason for that. There are many other reasons, but there is one reason. Spring allows you to use like external configuration. It may be XML, it might be Java config, more modern, but you need your configuration to be external, and then you need to be able to break it down into fragments. And remember about the system under test I talked about before? Well, you can define your system under test, and you need to define the configuration snippet that will wrap this up nicely. So this is a very simple example, but it can be applied to everything. You have like a service repository that depends on a data source. Nothing like mind-blowing. Service depends on the repository, depends on the data source. The data source is not defined in the main configuration file. It's defined in two places. There is like a prod configuration, production configuration. There is a testing configuration. And when you are in the test config, well, you assemble these fragments together. When you are in production, you assemble those fragments together. If you are using Spring Boot, you can use profile. It's not really important. The important is thinking about how do you fragment your monolithic configuration file. I mean, when you write code, you try to break down your stuff into modules, into packages. Configuration is the same. You need to think about it and design it adequately. This is the code that goes with it. So here I'm using like beans. I'm using a bean data source here that looks up to the GNDI stuff. And here I'm using like H2, and that's perfectly fine. And here you can see I'm using a set max active 1. Think about it. There is a question afterwards. How do you handle that? So here, for example, I'm using the Java config. So in my main stuff, I have the data source config and the main config, and in the test stuff folder, I have the test data source config. So it's very easy to assemble. That means that it's up to the client to assemble the fragment that it needs. It's fine. Something that burned me before, you don't reference each fragment inside each other. You really make either the web application or the test assemble fragment that are required. Set max active because who never had any pool exhaustion issue? Yeah, one guy. And that's great. I mean, that's a real issue. It happened to me previously, like some years ago, and basically the guys, they had to restart the server every day. Yeah, you can do it anyway, but that's not so funny. So you want this pool exhaustion issue to be checked, to be verified as early as possible. When it's in production, it's really bad. So if someone doesn't release the connection, check it as soon as possible. So during your testing, just one connection. And I would advise you for compile time safety to use Java config instead of XML, but up to you. Okay, but now how do you test? There is a framework for that. It's called Spring Test. One jar to bind them all. And you can integration test with like your normal standard, like JUnit, TESTNG, JUnit 5, whatever. So what you tell is you say, oh, I need those configuration fragments. You run with whatever runner you decided. It's IT, so it means that it will be run with the MAVEN FAILSAFE plugin, provided you configured it explicitly. And then you can like auto-wire what you need that is probably defined in the main config. And then you annotate it normally. I mean, nothing mind-blowing. This is the magic. This is where the magic happens. With TESTNG, you would just need to extend the TESTNG runner, but it's the same stuff. Now testing with the database. I mean, not everybody is using MongoDB. Some people are doing like transactions. Trolling again? Yeah, don't record that, please. Yeah, that's always funny that people are still using transaction for like money transfer and stuff like that. The problem with transactions is that Spring rollbacks everything automatically at the end of tests. So when a test fails, what's my first reflex? I want to check the database state to see what happens. It has been rolled back. That's not funny. That's the default behavior. I think that's the wrong behavior. I think it will never get fixed for backward compatibility reason. So you need to know about that stuff. In order to commit like a test, then you run, you annotate your stuff with @commit. And then you say, yeah, it's transactional, and then @commit. And if you really, really want, because for some reason, to roll back something when the stuff failed, then you use @rollback. End-to-end testing. I talked about integration testing being as soon as you make two classes collaborate, but it can be the whole application. And so basically the biggest integration test system on the test is the application itself. And then in that case, you want to test with the UI. And the UI is super fragile. Who has never written a Selenium test here? Oh, you are so lucky. I love you already. Who did? Who got bitten by it? Yeah. The problem is that the UI changes every time. There is a business owner coming to you and saying, no, the button? No, it's better like this. Not in the top left corner. I want it in the bottom right. And then it breaks every one of your Selenium tests because you didn't use any ID. You just use the normal CSS selector saying, hey, my button is in the top right corner. So the thing that, in general, the business doesn't care that much about is the URL. Okay, Spring provides something for it called mock MVC. So if you are using Spring MVC, mock MVC is the main entry point into your test stuff. And I mean, again, it's like fluent. Mock MVC perform get, post, put the URL, and you expect whatever to be whatever. Super easy. And now comes Spring Boot, because the Spring framework is a lot of effort to do the cake, and Spring Boot is, yeah, you can already eat the cake, you can smell it already. It smells good. With Spring Boot, if you are using Spring Boot, this is done for you. You get the mock MVC not by using a stupid builder. You say on the test, auto-configure mock MVC, and then you inject it, and it's done. The only difference is that using the application context to tell you which fragments you need, then you need the Spring Boot test stuff. Also something I'm not very fond of, but I mention it anyway. Your Spring Boot provides you specific annotation to test some layers. So if you only want to test repository, you can say, hey, this is a data GPA test. And if this is a web, you can use the web MVC test. I'm not that fond of this layer stuff because I'm more vertical, but you can use it anyway. We still have some time for the Java EE world. I'm more a Spring fan, but Java EE has a different view on stuff. First, I wouldn't say that now that CDI has no explicit wiring. You cannot say, I want to inject that, but it's more like, hey, let's parse everything. Now it has, but I guess that not a lot of people know about it, and even less people use it, really. And also, in general, if you are saying you are a Java EE compliant guy, that means that probably you provide a web application that runs on a lot of application server. I mean, that's the point. So you can say, hey, I am using Jenkins and I'm deploying it on Tomcat or whatever. Tomcat, which is not Java EE compliant, but you understood me. The problem with that is, since like it parses everything, is you need to define your system under test at some point. In that case, there is a library that lets you like deploy exactly what you want. It's called SHRINKWRAP. It's part of the ARQUILLIAN suite. And basically, you can choose which classes, which resources will get deployed into the application server for you to test. It has a very good MAVEN integration and the other tool too. So this is something that uses the SHRINKWRAP API. So you defined the sources of your web app. You say, I will create which kind of archive, what's its name. You say which classes explicitly you want to have, or because you are lazy and it makes sense, you want to include a whole package. You say, okay, I want this persistence XML, saying you can use the one from the real production app or someone you decided yourself. And then you can add whatever, like GSP, GS, or whatever you want into your, like, at the root of your application. And you also decide which deployment descriptor, if any, is necessary. So it's really pick and choose, and only because there are no specific like injection file, because everything is picked up, then you need to decide what you want to deploy. Of course, the smaller stuff you deploy, the better it is, because the faster the test will be. As I said, there is a MAVEN integration. So instead of saying, okay, I want that stuff and that stuff, what I do with my libraries, because I guess that not every library that you use is available from the application server. You probably have other libraries. Then you can like use the MAVEN resolver to tell the SHRINKWRAP to say, okay, I also want to deploy those libraries. In that case, I want to deploy the library that are like compile time dependency and runtime time dependency. It's the same, and it works. Other issue, you want to make sure that your application works on different application servers. So this is the realm of something called ARQUILLIAN. And ARQUILLIAN is an abstraction layer that will download whichever application server you need, deploy your application on it, and then run it. Last time I checked, there were like TOMEE, JBoss, 12 stuff. Perhaps depending on your application server, whether it's WebSphere or whatever, they also provide one adapter. You have to check. Again, it's fully integrated with MAVEN. And this is how it looks. So you have to extend the ARQUILLIAN stuff. You say that as for Spring, instead of AutoWired, of course, you use inject. You will inject the service. That is very important. You must provide a method that is static, annotated with @deployment, and this method will use a SHRINKWRAP API to return the artifact that you want to deploy. This is the first step that will happen. You will deploy your application. This is, you can name it however you want, but you need this stuff. And then afterwards, you have your test just like you would have in any normal stuff. I should probably stop using the word stuff. And this is the ARQUILLIAN configuration file. It's XML, sorry for that. And here you see that I'm using TOMEE, and I will say, oh, use any HTTP port that you find available and any stop port that you find available. And that means that if I provide this file to ARQUILLIAN, it will download TOMEE. You need also to configure it, in the POM file as a dependency, the adapter. And it will use Tomcat, it will configure it like this, and it will run your test on it. There are tons of extensions. There is one for DBUnit. DBUnit is super useful. You can use it outside of ARQUILLIAN as well if you want to preload your database with like test data. That is very important. And it also lets you check the state of the database at the end of your test without writing any SQL query. The issue is that what you preload and what you check, you must provide it in XML files, and that is sometimes not that great. But for like small cases, it works. You have integration with Selenium. I never use them, to be honest. Recently, they added an extension for Docker, which is pretty cool because everybody uses Docker, or at least you must pretend to use Docker. If you want to talk there, you must prove that you are using Docker. No, I'm joking again. Stop. Don't record that. And yeah, that's the end of the talk. You can read my blog. You can follow me on Twitter. I provide the book with 25% like discount if you want to buy it online. And now I guess this is the time for some questions. Yes, thanks. You saved my life. It's always awkward when nobody asks questions. Either I was super clear or it was the most shittiest talk of all your life. One question is better.
And you mentioned that you hate self-annotating classes.
Yes.
What did you mean exactly?
Well, it's a design issue. You are probably using like Spring to decouple your classes. Okay? And then you couple yourself to a framework. Not that great. This is my first issue with self-annotated classes. Second issue, when you annotate a class, you can only have one bean of this class in one scope. It can be only prototype or only whatever. You cannot have two beans named differently. Not that great. And if it's either prototype or session or whatever, it's defined. You cannot reuse it in any other way. That's my beef with self-annotated classes, because basically they pretend, I mean, at one point, I was using XML for a long time, and at one point when with Java 5, everybody like started using self-annotated classes because annotations are so cool. But guys, think about what you're doing. That's not a good idea. So that's nothing to do with testing in that case, but not a great idea. If you are using Java config, it's the same. You are using annotations as well, but at least your configuration is orthogonal to your source code. And you can change your configuration without changing your source code. It's philosophical as well. And besides, you cannot nicely create your configuration fragments. Or you could use SHRINKWRAP for Java EE to just take the classes you want, but then just use orthogonal configuration. Other questions? Everything was clear? Thank you very much.